Just because I need to upgrade myself in this Docker and Kubernetes things.
Okay, so
Yeah.
that's fine. Let's discuss about the basic concept of Docker and Kubernetes, and then we will go ahead into the concepts of. Uh, we will be diving into the major concepts of Docker and Kubernetes. So now, when we are working with the Docker and Kubernetes, the first and foremost thing there is why we want to have the Docker, why we need to have the Docker, why can't we go with the servers? So if you see in the good olden days, so somewhere like 2000 and 2010, between 2000 to 2010, in between that, we don't have the Docker, we don't have DevOps itself. Okay, now from the past 10 years onwards, DevOps has become a booming technology. Everyone are talking about the DevOps engineers where we need to have the complete automation. We want to learn about GitHub, Terraform, Jenkins, Docker, Kubernetes, Ansible, like that. So now, but previously, if you go back to 19th, like earlier 2000, so in 2000 to 2010, we don't have the Docker. We used to have the physical servers. So in the premises, in our company environment, or else in our company, there will be only a servers. Servers will be there. So when we are having these servers, so the servers will be huge. So if you are purchasing a server, the resources inside the servers will be very, very huge. You are going to get somewhere like 16 CPU, 256 GB of RAM, or 32 CPU, 500 GB of RAM, or 1 terabyte of RAM, like that. So inside this physical server, what you are going to do here is inside the physical server, you will be installing the operating system. Either it might be Linux operating system or else it might be Windows operating system, any operating system that you will be installing. Just in case, I will install the Linux operating system. So when I install this Linux operating system, in Linux, most probably Java and Python will be easily configured. Java and Python can be easily configured. But when you see the .NET, of course, .NET is also, we can also install the .NET on the Linux environment. But majorly, .NET framework will be most probably used with the Windows environment. So if I am wrong, please try to correct me. So whoever are the .NET developers are there, you can also tell me that. Why? Because one thing that I want to tell you, I am not into the development. I am into the completely purely starting from my starting career onwards. I am into the system administration. So I don't have to feel sad about that. I don't know about the development. But yes, I know how to build the application, how to deploy the application, how to manage. How to make it available for the end customer. I know the end-to-end process, but I don't know what is the source code and all the things. What you are going to write in the source code and all the things. If there is any mistake, correct me. Okay, no problem. I will take it. But anyways, coming back to the point, so .NET. So .NET kind of applications will be a little bit difficult to run in the Linux environment rather than in the Windows environment. In Windows, I can easily run the .NET applications. Anyways, the other point is that, for example, in this Linux environment, I want to create a Java application. So I'm creating a Java application, Java 17 or Java 8 application. So let us go back to the olden days. Now we are having Java 22 is there. Java 25 is also about to roll out. So now we are having, previously we used to have Java 1.8 or like Java 8, we'll call it as. For example, I am running an application with the Java 8 version. When we are running an application with the Java 8 in the same server, in the same physical server on the top of your operating system, if you want to create another application with the updated Java version, that is either with the Java 11 or Java 17, with the higher dependency configuration, this application app 2 will be running with uh, the application 2 will be running with Java 17 or Java 11. Let me take Java 17. The application will be running with Java 17 and the previous application will be running with Java 8, and that too with the older dependencies. So the dependencies will be old. And here we want to run this application too with the new dependencies. There are certain dependencies will be there, or else whatever the internal applications that we are using, we need to use the new applications for the, or else new services for the application too. For application 1 to run, we need to run the old services. Now, if I have to do like this, can I do in a single server? Will this work out in a single server? Do you understand my question? Do you understand my question? If two applications with the two different dependencies, will they run in a single machine? That is my question. Hmm.
No, we cannot run. We have to uninstall and reinstall.
Either we have to uninstall any one of the application and then we have to reinstall that. Otherwise, what we have to do, we need to create another physical server. So creating the physical server is that much easy. So to create a physical server, we need to go through so many things. First and foremost thing, if you want to purchase a physical server, no, I am talking about the olden days, not now. Now we are having the cloud environment, which we are going to get the servers. The servers will be easily, we can easily roll out the servers and we are going to get them for the rental basis. So the point is, in the olden days, if I want to have a server, first of all, I need to get the quotation from the OEM, and then the accounts team has to approve that quotation, and then we have to create the we need to bring out the server. So to get the server, it will take another 2 weeks, and then we need to do the server hardening. We need to do the security threats, and then we need to install the we need to install the operating system and check out for the security. Is there are any threats are there on everything is fine, if there are any vulnerabilities or not, any bugs or not. So everything we have to check, and then finally we need to connect it to the network. Then we have to install the new application. But think once, purchasing the server itself is a very costly one. And whatever the application that we are installing, the application will not consume the entire resources. See, whenever you are purchasing a particular object, or else if you are purchasing a computer, or else if you are purchasing your mobile phone, why you will purchase without using the mobile phone? Will you purchase the mobile phone? You are purchasing the mobile phone for watching the videos or else doing certain works, playing games, talking with each other. Previously, we used to have the phones only for communication, but now we are having the phones for all the things. You can access the websites, you can watch the videos, you can do the editing, anything can be happen with the, you can take the camera, you can take the beautiful videos, photos, everything can be happen with a single mobile phone. So if you are purchasing a mobile phone without using that mobile phone, all features, what are the features that are available for that mobile phone, if you don't use all the features, then what is the need of purchasing it? For example, if you purchase an iPhone, so when you purchase the iPhone, if you want to only talk, then why you need to purchase an iPhone? iPhone is not, that has become a status symbol. But anyways, if someone says that I have purchased the iPhone so that I can show to my friends I have an iPhone, but he doesn't know any single feature of that iPhone, then what is the use of purchasing that? Just to display. So in the same manner, here also, whatever the physical servers that you are having, if you are running an application inside the physical server, if the application is not utilizing at least 80% of the resources, or else if at least 50% of the resources, then why we need to have an server? So that is the main problem with the physical servers. The main problem with the physical servers is that the component utilization, optimization of component utilization won't happen. We can run a single application. The single application maximum it can consume up to 2 CPU, 4 CPU, 32 GB of RAM, or else 64 GB of RAM. In the worst cases, it will be going beyond 128 GB of RAM. For example, if I purchase a server that is having 512 GB of RAM, then what is the use of purchasing that much huge amount of servers? So these problems, whatever the problems that I am facing on the physical servers, these problems are overcome with a concept called as virtualization. Then the scientists or the IT industry has introduced a new concept called as virtualization. Now I hope you understand what is the problems with the physical servers. What is the problem with the physical server? What will be the problem with the physical server? Tell me, guys. What do you understand from this? What is the problem with the physical server?
Maintenance and cost.
maintenance and cost, and as well as optimization of resource consumption won't be there. Okay. So to overcome that, what we have done, we introduced a new concept called as virtualization. So now what is this virtualization? Virtualization is a concept of what we can do here is whenever I am having a server. So for example, I created my virtualization in my own location. So I have a physical server. Inside the physical server, okay, so this is my physical server. Inside the physical server, I created the virtualization, or else I installed the virtualization software. So whatever the physical server that I am having right now in my home environment, the physical server is of some, what I can say, 8 CPU and 64 GB of RAM. So this is my physical server. So whatever the physical server that I have purchased, that is what I am having. These are the resources which I am having. Inside that, I installed a software, or else install an application called as VMware ESXi. Okay, I installed the virtualization software called as VMware ESXi. Inside the VMware ESXi, what I am going to do here is, 1 second. So inside the VMware ESXi, I am going to install the applications, whatever the applications that you are seeing. I mean, let me show you the applications, or else let me show you the virtual missions here. So here, what I will do, I will create a virtual mission. So this virtual mission will gather the resources from my physical hardware. So whatever the VM that I am creating here, VM means virtual mission that I am creating here, this virtual mission, I will make it as VM1, and I will provide the resources like 1 CPU, or else let me go with 2 CPU and some 16 GB of RAM to run the applications. So this is more than enough for me. So inside that, I will install an operating system. Inside this virtual machine, I am going to install an operating system. And then what I can do here is, inside that operating system, I can run the application. So here I will install the Ubuntu operating system. Ubuntu operating system. Inside that, I can run the application. So now if this application wants any CPU and RAM, then it will communicate with the Ubuntu operating system. If the application, if whatever the application that you are seeing, if this application want to run, then it needs to have the CPU and RAM. Without CPU and RAM, the application will not run. Without resources, how it will run? It won't run. So it need to have the CPU and RAM. So when it requires the CPU and RAM, the application will communicate with the Ubuntu environment. So Ubuntu operating system will communicate with the virtualized machine, and from the virtualization, the application is going to get the resources. Now, who will provide the resources to this virtual machine? The resources which are provided are from the physical hardware itself. So to make sure you understand this, I already have my virtualization in place. Let me show you. This is my internal server, which I have created for my demo purpose. Okay, so this is my VMware ESXi client. Okay, just to show you. Anyways, I'm going to try and the candidates on the VMware also. Now, if you see these, how many virtual missions are there? I am having 3 virtual missions: Kubernetes master, worker, and worker 2. So if you see the host means the server which I have installed, it is having 32 GB of RAM. So the total memory which I have provided is 32 GB, and the CPU is around what I can say 8 CPU I have provided, and the storage space is this. So I have my server in contact. Now inside that virtual mission, so this is the server. Inside this server, I created some virtual missions by using the software called as VMware ESXi. I created these virtual missions. When I create this virtual missions, inside them, what I can do, I can install the operating system and I can run the application. So I'm running the application. So there won't be any problem when they are running. So like that, what I can do, I can create multiple virtual missions, not a single virtual mission. I can create multiple virtual missions depending on the requirement. For example, some virtual missions will be they want to have on the Windows environment. Like previously I said I want to run a .NET application Rather going with the Linux application, I mean Linux environment, I will go with the Windows operating system. So if you see underlyingly how many physical servers that we are having, if you can see here underlyingly how many physical servers that I am having, only a single physical server is there. So within the single physical server, how many virtual machines that I am creating? I am creating multiple virtual machines. So this is the virtualization technology. If I have to make it very simpler for you, you have a hard disk. So the hard disk is of size one terabyte size of hard disk is there, which is some huge amount of hard disk for normal user. So if you want to break the hard disk into small portions, so for C drive I want some 400 GB, for D drive I want 300 GB, for E drive I want 300 GB. Now for the three different drives we want different storage spaces. Are you going to physically break the hard disk into 400 GB hard disk, 300 GB hard disk, and 300 GB hard disk? Are you going to break it physically, or else are you going to divide that hard disk logically into partition? How you are going to do that? Do you understand the question or not? Can I repeat the question again? Okay. Now let me reiterate the question in this fashion. You have a hard disk in your computer. You have a hard disk. Now that the hard disk which I am having is of size 1 terabyte. The hard disk is of size 1 terabyte. Now my requirement is that I want 400 GB of hard disk for system files, like operating system files. 300 GB is for my office purpose and 300 GB is for my personal purpose. Am I going to break the hard disk into the pieces? Physically, am I going to break the hard disk into pieces so that I can get 400 GB, 300 GB, or 300 GB? Or I am going to divide the hard disk into logical partitions so that I can get drives? What I am going to do, or else what you will do? You tell me in your perspective. Just imagine what is my question and tell me in your perspective. Come on, guys, speak. See, one thing I want to tell you: the people who are able to communicate with the faculty. So these sessions are for them only. I did not ask you any technical, very technically difficult question. I just asked you a simple question and I reiterated for 2 times. If still you did not understand, tell me I did not understand. If you understand the concept, give me the answer. Don't sit idle. So again, if it my words might be looking like harsh words, but the point is very clear. I want the students who will be communicating with the faculty. I don't want the students who are sitting in the class. If I get the students minimum two who will effectively talk with the faculty or else effectively talk with the trainer, I want those two students. That's more than enough for me. Why? Because I'm not here to earn the money. I'm here to gain the knowledge. I'm here to gain knowledge in the sense I'm here to provide the knowledge, and as well as the vice versa, I need to gain the knowledge. Both the ways I am trying. So then it is very healthy if we have a discussion. If you are sitting silently in the session and not at all listening, or else if you are trying to sit calmly, then this is not the session for you. You can happily leave the session. I don't have any problem. My request is that please stop. Do you understand the question, or else do I need to repeat the question? Do you understand the VMware concept or not? So if you understand what you understand about that, please tell me about the concept which you understand. That is my question.
Yes, sir, I understand the concept. Like we have to create the logical volumes for each VM and assign to that.
No, it's not about the logical volume. So now my question is, I have a hardware. Okay. In the same manner, previously we used to have the physical server. How we are having a physical server, inside that physical server, we are using the entire CPU and RAM for a single application. But I want to make it optimization. So for that reason, what I have done, I went for a virtualization concept. In virtualization, whatever the physical hardware is there. So now if you see here, we have purchased a physical server. So this is the physical hardware which we have purchased. On top of that, what I am going to do here is I am going to install an operating system, or else I am going to install the VMware virtualization software, VMware, Citrix, hypervisor, like that. There are so many virtualization softwares are there. So any software I can use. Virtualization. I am using this software like VMware ESXi. On top of that, what I am doing here is I am creating a server. Okay. This server is not the physical server. This is a logical server or else a virtualized server. So that's why it is called as a virtual machine. So now if you see here, when I turn on the Kubernetes master, okay, from my what I can say, from my virtual machine, if I turn on the Kubernetes master, a new server is created and I can access the server. I can run my application inside the another server. So a server inside a server inside the physical server. So this is the virtual machine, logical machine, which I have created. On top of that, what I am going to do here is I will install the operating system. So this is your VM. On top of that, I am going to install the operating system. On top of this operating system, I am going to run an application. Okay. So to run this application, how much amount of CPU and RAM that the server wants, that the VMware wants, or else virtual machine wants. For example, 4 CPU or else 2 CPU, some 8 GB of RAM. So this 2 CPU, 8 GB of RAM will be given from your hardware, the physical hardware, the physical server. And if there is, if I want to create another virtual machine, I can create the other virtual machine where the same configuration. This is VM2, and I am going to give the virtual machine the physical, hardware from the physical server. On top of that, I can run the operating system and I can install another application. So you can run the multiple applications with multiple dependencies on the virtualized missions. Okay. So now what is the problem with the virtualization concept? So the main problem with the virtualization concept is that whatever the hardware virtualization that you are seeing, the main problem with the virtualization is that, so whenever you want to run an application or else whenever you want to migrate the application from one environment to the another environment. So now what is this environment? So in IT industry, how many environments will be there in general? How many environments will be there?
3.
Sir, dev, QA,
Very good.
UAT,
Dev,
pre-XCT, and
production.
prod.
I will go with the
Yeah.
prod.
Yeah.
Actually, there will be mainly 3 stages will be there. Okay. I will call them as UAT. Some companies will have internally, they will have another multiple stages, but as per my, in general, there will be 3 stages. One is the development stage, and the other one is the UAT stage, UAT or staging stage, and the third one will be production. There will be pre-prod will be there. That is nothing but the staging. Okay, some companies they will call it as pre-prod. There will be QA stage will be there. So I will call them into a single stage. That is the development stage itself. Under development stage only, you will have the QA itself. So depending on the company, the stages might be different, but basically you will have 3 stages. One is dev, staging, and prod. So now, for example, if you create an application, let me give a small example for you so that you will understand it very clearly. In the entire world, there are basically 2 types of companies are there. What are the 2 types of companies? The first one is IT company. The second one is non-IT company. Requester and producer. Okay, so there will be requester and the producer will be there. So here, non-IT companies will come under the requester category. So where they are requesting the application. IT companies will come under the producer category, where they are going to provide the necessary applications for the non-IT companies. Okay. Now, what I have to do here? For example, let me explain you. Just imagine yourself. For example, you are having a small business. You are into e-commerce website or else e-commerce product category. You started a business, or else you are having a travel agency. For example, I am having a travel agency. Now I want to provide the services to my end customers. So to whoever are the customers are there, for them, I want to provide the travel services. I need to provide the travel services in budget, and as well as I have to tell them the itinerary, how many days of trip it will be, and what are the inclusions and what are the exclusions, how many numbers of people are traveling. Everything I have to give it to my customers. So I set up my office in some of the location. In one of the location, I set up my office. So now if some people from a distinct location, so I set up my office in Hyderabad. For example, there are the peoples. There is a friend group in Bangalore, so they want to go for a trip to some Bali or else some another Thailand or else any another country. So what they have to do, they if I have in the offline, so if I have my office in offline environment, then they won't come to me. So now what I have to do, I need to go near to the customer. Nowadays, customers are not coming to the company, or else customers are not approaching to the business shops. Business companies, business owners has to go to the customers. Now what I will do, I will tie up with an IT company. When I tie up with the IT company, what I will say here is, sir, I have zero knowledge on the IT. I don't know what is meant by dev, what is meant by prod, what is meant by UAT, what you will be doing. But my requirement is that I don't want my customers to feel sorrow or else to feel bad about my company, saying that this company doesn't even have a proper website. So I need to have a web application. Okay. So I am talking in the technical terms. As a non-technical guy, what I can talk here is, sir, I want a website. So inside the website, the user has to log in, and after login, he has to check out the list of travel and then list of trips, and then he has to select one of the trips, and he has to be getting all the itinerary. And after getting the itinerary, if he is interested, then he will be booking that. When he booked that itinerary, or when he booked that trip, it should go into the payment page, and payment has to be done. Once the payment is done, it should be going to the notification. So the user should get a notification. So like that, I have explained my requirement. So now, as an IT guy, what you are going to do? You are into the IT field now. So what you will do, or else what you will explain to this non-IT guy? Tell me, if you are an IT company people, what you are going to explain to this non-IT guy? I'm a non-IT guy. I don't know what is Java, what is Python, what is system administration and all. What you will explain to me and what you will convince to me?
Take the requirements like how many end users will access the website and
But as a travel agency, I cannot say you how many end users will be there. No? So there might be some days it will be 10. Depending on the season, it might be changed. So the point is, you will be saying, you will be asking, okay, sir, I will create the application for you, and it will take some time. And whatever your requirements are there, we can try to fulfill that. But as a POC, proof of concept, so you won't say this. So you will say that in a non-IT terminology only, but you know about POC. As a proof of concept, we are going to design a small application for you. If you like that, we can proceed ahead into the main application. For POC, it is going to charge this much amount. So you are going to charge everything, and you will explain it to the non-IT guy. So you don't need to explain any IT terminology for the non-IT guy, but you have to gather some information, like as you said. You can ask him. So how many people you will get in summer? Whether you will get a large amount of people or a low amount of people. So these things you can ask him, and you have to ask him. Do you have any official email ID? Do you have any official phone number? Why? Because we have to include that in the website. And finally, now it is time to disclose in front of your team. So you have to tell this to your team that we need to develop an application, and this application will be having this microservices. If you take the same travel agency application, so what are the microservices that we can have in that application? We can have the front end microservice, and in the back end, I can have the user management service, payment service, notification service, and then what else I can have? Yeah. So these are the few microservices that we will be using, and as well as in the background, we will be using the database called as either it might be PostgreSQL or else it might be MS SQL, and as well as we need to have an Redis in memory cache. So this is the entire application architecture. So you will explain it to the developer. So the developer will start developing the application. So when the developers are starting their application, when the developers are trying to create the application, and they will give it once the application is completed, so they will test the application on their laptop. Try to understand this very clearly. They will test the application on the laptop. But when they give the application to the system administrator or is the DevOps engineer or cloud ops engineer in the server environment, the application will not properly work. Have you ever checked this, or else have you ever landed into this particular situation? So the developer will say that it is working in my laptop, but it is not working in the server, or else it is not working in the EC2 instance. Have you ever landed onto that type of scenario?
Many times
Yes.
works on my
Yes.
machine.
Yeah, works on my machine. It is not working on the other environment. So I don't. I want an application that doesn't have an environment dependency. So independent of environment, I want to create the application. So there comes the concept of containers. So if I have to tell you in a very simpler manner, so you got promotion and you invited all your colleagues to your home, and you prepared a food. Okay, you prepared a dish. So in your home, you have all the ingredients to prepare the dish, and you prepared the dish, and the dish came very well, and everyone are praising you for that dish. So the taste is excellent, the texture is excellent. So we love this dish. One of your colleague has came to you and asked that, can you please provide the ingredients? Can you please provide me the recipe so that I can recreate in my home? So you provided the recipe. When you provided the recipe to the colleague, when he tries in his home, the food or else the dish might not come as it is. Okay, it will be something different. Why? Because of the environmental differences. He might be using different ingredients. He might be using the ingredients in a different quantity. Whatever the quantity, the ingredients that you have used, he might not be using the same quantity. So the environment will be different. In the same manner, when you come back to the same scenario in the company, so in the developer's laptop, they will be running the application in a particular dependencies. So if they want any dependencies for the application, they will download and install the dependencies on the laptop and they will run it. They won't see whether it will be running on the server or not. What is the requirement of developer? Developer requirement is that he has to develop the application and submit it to the administrator or else the DevOps engineer. So the headache is with the DevOps engineer itself. So the DevOps engineer, when he tried to create that application in the server will not accept. Why? Because already inside the server, there will be few applications running with the older dependencies. And whatever the new application that we are creating, it is coming up with a newer dependencies. So there will be a conflict. Application compatibility issues will be done. So you will say the same with the developer. The developer will say that no, it is running fine on my computer. So why it is not running on your machine? It is your machine fault. They will simply throw blame on us. Okay, I'm not degrading. I mean, I'm not saying anything related to the developer, but the point is, this is how the situation is all about in the IT company. So now what happens again? DevOps engineer will say that no, it is not running. You have to change the compatible. I mean, you have to change the versions. Then this conversation will keep on going, and the application will be delayed, and customer will simply call him to the company, and he will start scolding, and lot of things will happen. So now to overcome this problem, what I have to do? Either I need to create an application that is independent of the dependencies. We cannot create any application that is independent of the dependencies. Then what I have to do? I need to create an environment such that the application can be running in any environment. So that can be created with the help of containers. So what is a container? So now if you see here, when we are talking about the containers, container is an software virtualization where we are going to install the dependencies, okay, where we will be having the application and application dependency. Now, how this containers will be working? So the containers will be working same like your virtualization, the containers are also going to work. But there will be a small difference. You will have the hardware. On top of that, you are going to create another layer called as operating system, and this is called as host operating system. Now, if you see, this is the hardware. On top of that, you will be having the operating system. On top of the host operating system, you are going to install an application. And this application is called as a Docker application. Docker or else any containerized application, either it might be Docker or else ContainerReddy, any application you can call. Okay, so I will be installing the Docker. On top of this Docker, I'm going to run a container. I'm going to run a container. So inside this container, I can create the application. Inside the container, I am going to create the application. Now the point is, this container is completely, it doesn't require any sort of, here I am not going to create any sort of dependencies and all of it. So here we will be giving only the application and its dependency. Now what we can do here is, if I want to migrate this container from one environment to the another environment, I can simply pack this entire container and transfer it to the production environment. There I can unpack it, or else what I can call as, I can convert that container into an image format, and I can create another container in the another server. So when I create the another container in the another server, so then there won't be any dependency issue. Why? Because whatever the dependencies are, else whatever the application dependencies are there, all the dependencies are there inside the container only. Okay, they will not be installed on the host operating system. They will be inside the container only. So now, as the container is unpacked, or else as the container is created in the production environment, there the application will be running without any problem. So likewise, as I have already said you, there is no compatibility issues will be coming for the containers. You can simply migrate the containers from one environment to the another environment, and you can run the application on the different environment also. So this is the main use case of the containers. Now, virtual machines are also doing the same. No, in virtual machines also, you can migrate virtual machine from one hardware to the another hardware. But what is the main problem with the virtual machine here is, whenever we are migrating the virtual machine, we have to migrate the entire unwanted dependencies also. For example, if I have to take a layman's example, you in your home, for you it will be, there will be a separate computer desk will be there, there will be a separate computer, there will be separate bed, there will be separate AC, and there will be everything. You will have your own laptop, and you will have your own wardrobe. Now whenever you want to travel, are you going to carry all the things with you, or else are you going to carry only whatever the required things? How you are going to travel? Will you travel with all the computer, AC, wardrobe, bed, and all the things with you, or else are you going to pack only the required clothes and you will travel to the destination? How you are going to do that? Do you understand the question?
What is required, we'll take it up. Not all.
Whatever, you won't be taking all the furniture with you, right? You will be taking only the required things. In the same manner, whenever we are working, if you take the virtual machine is like taking all the furniture with you. So whichever are required or not required, so it doesn't matter. So in virtual machine, when we pack the virtual machine and transfer from one environment to the another environment, then definitely what is going to happen? You are taking all the furniture with you. You are taking all the dependencies, all the whatever the dependencies that not required, you are taking all of them. But when you come to the container, inside the container, what you will have here is, you will have only the application and application dependencies. Even kernel will not be there inside the container. Even we are not going to install the operating system. A container is just a piece of process which will be using the operating system environment. It is not going to have the operating system inside it. So container will use the operating system environment. Okay, so it will not have any kernel. Now, what is meant by kernel here? Does anybody know what is a kernel? kernel in the operating system. We have the operating system, no? Inside the
Heart
operating
of
system.
the operating system now, right, sir? If I
Yeah.
recollect.
Kernel is like an heart of operating system. Now, if I have to define that, kernel is the base component of your operating system, which will do the process management, memory management, network management for your application. If you start an application, for example, if I start the Google Chrome, how much amount of CPU that the Google Chrome has to utilize, how much amount of memory how much amount of RAM that should be allocated to the Google Chrome application. Everything will be decided by your kernel only. So if there is no kernel, the application will not be started. So to simply explain you that in 1970, we have our first Unix operating system. Okay, that is developed by Ken Thompson and Dennis Ritchie. And later in 1980, there is a person called as Richard Stallman who has came into the picture and said that, so the Ken Thompson, the Unix environment is completely, the Unix operating system is completely a premium operating system, like how you are purchasing Windows and Mac. In the same manner, we used to have the Unix operating system, which is totally a premium version. You have to purchase it. So this Richard Stallman came front and said that already I am purchasing the hardware. Why again I need to purchase the operating system? I will prepare my own operating system. So he started preparing his own operating system, and that operating system is called as GNU operating system. He started a GNU operating system, but he created all the application, but he failed to develop the kernel. So he is unable to develop the kernel. But in 1991, there is a person called as Linus Torvalds who has invented the Linux kernel and attached that kernel to the GNU operating system. And they prepared a new operating system called as GNU Linux, on which the first flavor was introduced. So that much important is kernel. So without kernel, the operating system will not work. So in the virtual machines, we are directly installing the operating system. In the virtual machine, directly we are installing the operating system so that we will have the kernel available inside the virtual machine. But the main problem is that if I pack the entire virtual machine, it is going to have huge amount of space. It is going to take huge amount of space. Now, when you come to the containers, in containers, we will not have the kernel. So we will not have the operating system. We are going to use the binaries and libraries of the operating system. We are not going to install any operating system, and we will not have any unwanted dependencies. In containers, you will be having only the application and application dependencies. It won't have any another thing. Then how application will run? So the point is that, so without kernel, how application will run? So now what this application will do here is, application which is running on the container will talk to the operating system kernel and request the hardware for running the application. So there is an host operating system now. So the kernel or else the container will communicate with the host operating system, and inside the host operating system there will be a kernel, and it will communicate with that kernel, and this kernel will allocate the requested amount of CPU and RAM to the application, and then the application will be running. So now the point is, the application, whatever the application that is running on your container, it doesn't even want the kernel. So they have designed the Docker in that manner so that the applications and as well as the containers can be utilizing the physical operating system or else host operating system kernel to get the resources from the physical server. So in such cases, whatever the application that you are running on the container has become very lightweighted. So simply we can run this application on any environment. So that is the main use case of your containers. So with the help of this feature, we have developed the containers. Inside that, we are running the application. And then we are going ahead into the containerization platform, like they have developed the Docker, Containerd, RKT, Podman, so many different types of containerization applications are introduced into the IT world. Among these containerized platforms, we are going to discuss about the Docker from next session onwards. I hope you understand why we have migrated from physical server to the virtual machine and from the virtual machine to the containerized platform. So tomorrow we will discuss about the complete containerization, and then we will go ahead into the concept of Docker and container, Docker architecture, container architecture, Docker networking concept. So that is from my end. If you have any further questions, you can ask me now.
So to summarize, virtual machine, we had this like in virtualization, we had the issue was like if we are creating one inside the virtual machine one VM to the other VM, we need to have like it will come with its own kernel, but when
Yeah,
it
it will come its own kernel.
comes with the Docker. So when it comes to Docker is going to share the physical OS kernel.
Yeah, the host operating system kernel.
Okay. So if my my next question, sir, if the Docker image which I created, the container is of Linux,
I know this
and the
question will
operating
come.
system which is on the physical machine is a Linux.
No, the operating system on physical
Sorry.
machine is the operating system on the physical machine is Windows, and you are creating a container with the Linux environment. That is what your question is, right?
Right. Yeah. So then, because
So
the operating system kernel is in yeah.
I understand that. Let me explain it. Whenever we are creating Docker, see here in my Windows environment, I am having the Docker installed. So that is Docker desktop. Whenever you are installing the Docker desktop to run the application, definitely you need to have a software called as WSL. WSL means Windows Subsystem for Linux. So this will manage the communication between the Linux containers to the Windows kernel. Without WSL, you cannot install the Docker desktop on your Windows environment. Definitely, you need to have the WSL installed.
Okay.
Got your answer for the question?
Yeah. I got my answer. Yeah. Thank you.
Yeah. Any questions, guys, further? Okay, then. So that's it from my end. Tomorrow we will meet at the same time at 9:30 a.m. and then we will continue with the concept of Docker and Kubernetes. Very interesting concepts are coming to our upcoming. So we have to understand about the Docker, and then we need to understand about the Docker networking. We need to understand about the Docker architecture, life cycle, and all of that. So we'll discuss in the next session. Okay. Have a nice day and bye, guys. Thank you all.
Thanks for nice explanation, sir.
Thank you.